Dear students, in the last class we studied about Bernoulli's principle, okay, and its application. One of the applications that was Torricelli's law. Today's class we will be going to see some more applications about this Bernoulli's principle. Okay, the first one, what is about venturimeter. Okay, venturimeter is a device which is used to measure the speed of fluid flow. So this part is not in your syllabus. Okay, you can there is a less chance of getting some questions from this part, but still for your understanding I'll explain a bit about this. So venturimeter is used to measure the flow of fluid, okay, or the speed of flowing fluid. The application mainly used in automobile carburetors. Okay, carburetor you must be knowing, right, where the petrol and air gets mixed. Then it is also used in filter pumps or aspirators. Then used in Bunsen burner, it's one of such burners which will be used in your chemistry lab. Then it is used in atomizer and also in the sprayers. Okay, that's all about this venturimeter. Only to know what is venturimeter, then some of the applications. This may not be asked for your exam. Okay, next thing, and is very important actually, that is how Bernoulli's principle can explain the blood flow and heart attack. So you people must have heard about heart attack, right? So it's a severe condition where the person will not be able to take proper breath and you will be having a lot of pain on his chest. Okay, so veins will be like if a person is having high cholesterol and all, what actually happens, you can see here, if this is the vein, okay, so people with the biology background will understand it much better. Okay, even those computer science students can also understand it. If this is considered to be a vein, when you have like a high cholesterol and all, cholesterol, you can see fats will be getting deposited on the walls of the veins. Now what actually happens, you know, right, vein actually carries blood, so blood will be flowing like this. Okay, maybe you can take the reverse direction also. We have different types of veins. Okay, now if a person having high cholesterol and having a lot of deposition of fat on its vein, what actually happens, this area actually decreases, correct, right? So you know from equation of continuity, what was it? AV is equal to constant, correct, right? So when a fluid flows through a pipe, the product of area and velocity will be always constant. Now you can understand here, when the area decreases, what actually happens to the velocity? Velocity increases, right? Correct? Velocity increases. Now when you have a vein with the fat deposition, the blood which is flowing through this one, okay, will have high velocity. Now when there is high velocity, you need to understand what happens to the pressure. When there is high velocity, the pressure on that area decreases. When there is high velocity, pressure actually decreases. When the pressure decreases inside the vein, what happens? Due to the external pressure, the vein gets collapsed. It shrink agate. Okay, what actually happens when the blood flows through the vein with very high speed? After the blood flows, what actually happens? It gets shrink. Okay. Now, what the heart has to do? It should open this one, right? So when the blood flows, what happens? The vein gets shrink. Now to open this, the heart has to apply like the work, whatever the heart was doing, the work has to be increased, like you know, right, the pumping, it has to do much higher pumping. Now when it does much higher pumping, what actually happens, the closed vein will again open, but you need to know that the work was very high, so it will have more energy, and again the blood will flow with a very high speed. Blood will flow with a very high speed. Now you can understand the same previous condition. After the blood flows, what happens? Again, pressure inside the vein decreases, so that because of the external pressure, vein again collapses. Now, if this process continues, this process continue ಆಗ್ತಾ ಹೋದ್ರೆ, what is going to happen after some time? The vein is going to get damaged. So vein damage ಆಗುತ್ತೆ. Even otherwise, the heart will have certain problems. So heart will stop functioning due to it will get tired after doing so much of extra work other than the normal vein. Okay, so that's the reason why there is a chance of getting heart attack. Okay, so this heart attack on the basis of this idea can be explained on the idea of Bernoulli's principle. I hope it is clear for you people. So okay, so what happens when the blood passes through the vein? Okay, area is less means velocity will be more, so it passes with the high velocity. When velocity is high, pressure is low, so vein gets collapsed. Okay, then to open it, heart will have to apply again higher work. Okay, it open, then again blood flows with a very high speed, again it collapses. So repeatedly having this process, lot of chance of getting this heart attack. Okay, so you can just read the textbook. If you need, NCERT textbook gives you very good explanation, or else you can just try to understand or analyze by yourself. Okay, next one is about dynamic lift. Okay, so you people all watch cricket, right? So I hope you are very much interested, maybe cricket or football also. So those who are not interested in cricket, you people also watch football, right? So this idea applies to both cricket and football. Okay, so very simple idea. A ball is thrown without spinning. Okay, just throw like this. Then how it actually affects the air surrounding it, you can see from this diagram. Okay, if I throw this ball without spin, it is going to move straight. Okay, and there will not be any change on the pressure on the upper side of the ball or the lower side of the ball. Okay, and the air will be flowing in the opposite direction. Obviously, when you throw this, the whatever air will be flowing in the opposite direction. So when you throw the ball without spin, there is no change in the pressure on the upper side of the ball or the lower side of the ball, and there is no spin, right? There is no spin. At the same time, when you throw the ball with a spin, so you know, right, you must have seen in the cricket like how the bowlers spin the ball. They use some tricks, right? See, if you do like this, the ball is going to spin, correct? If you do like this, again it is going to spin like this. You can see like clockwise or anti-clockwise. So both the rotations are possible. Okay, so we will consider one such rotation. So the ball is moving forward with a spin like this. Now you see here, it spins like this. So when it spins like this, you can see here on the top of the ball, the air particle, okay, will be taken along with, okay, with very high speed. Like whatever air particle over here will be moving with the high speed as the ball spins. Okay, when the velocity is more, what actually happens to the pressure? Pressure actually decreases. So ಇದು spin ಆಗ್ತಾ ಇರುವಾಗ, whatever air above this will move with the higher speed. Okay, then what happens? The pressure will get reduced. Pressure decreases. When the pressure decreases, you can see here, pressure on this side is let me consider P1. Here it is P2. Okay, so P1 is less than P2. When P1 is less than P2, what actually happens? This ball is going to have a upper push or pull, we can say, whatever, push or pull. It will have a resultant direction on the upper side. So same experience you people will experience, same idea you can experience if you go and stand near a railway track and there is an express train passing or moving on the track with very high speed. If you stand near the railway track, you people will be pulled towards a train. You must have heard this one somewhere. If you stand near the train, what actually happens? You will be pulled towards a train, not away from the train. Correct, right? Why it is? As the train moves like this, okay, what actually happens on this direction? If it is moving like this, the velocity of air over here will be more compared to the velocity of air on your side. If you are standing over here, when velocity is more over here, what actually happens? Pressure will be less on this side, pressure will be more on this side. So obviously there will be a resultant movement in this direction. You know, right? Air will always move from high pressure area to low pressure area. You people have studied in your lower classes, like if you keep water, okay, why water moves from tank to the tap? Because here pressure is more, here pressure is less. So obviously there will be a movement of water from high pressure area to low pressure area. Similarly, here also the ball is going to move upward. It will have a resultant lift. Okay, that is what we call dynamic lift. Okay, now dynamic lift due to spinning is known as Magnus effect. So this dynamic lift due to the spinning is known as Magnus effect. Maybe ask for 1 mark. Okay, and this part is very, very important. You need to study this one. Maybe 1 mark, 2 mark or 3 mark. You can expect this one. See, if you read NCERT textbook, it will be very clear and it is neatly explained on the textbook. Or you can just try to understand same way. When the ball moves straight, nothing happens. Pressure above and below remains same. At the same time, when it spins, the pressure above decreases. See, you see this, when it spins like this. At the same time, when it spins like this, there is a dynamic lift, that is actually downward. Direction will change if you change the rotation. If it is clockwise, there will be upward. If it is anti-clockwise, obviously there will be downward. Okay, so this is about ball moving with the spin, explained on the basis of dynamic lift and the Bernoulli's principle. So Magnus effect is nothing but dynamic lift due to spinning is known to be Magnus effect. Now we will see aerofoil or lift of an lift on an aircraft wing. So you people must have seen the takeoff and the landing of aeroplane. So aeroplane has got wings, right? So it is stretched in this way, and you people observe carefully. You can see the wing actually moves like this. When it is taking off or on the time of landing, you can see that the wings will not be stable all the time. It is going to move like this, okay, like this or like this. So why it does so? It is to stabilize the weight of the aircraft, okay, during the time of landing or the time of taking off. Now we will explain this on the basis of same idea whatever we have seen here. So we have something called aerofoil. Aerofoil, you see, you people when you were very small, you used to make aircraft, right? So rocket we say. We used to fold the paper, then again fold, then you used to blow the air and you throw. So when you throw, you people must have observed, as you throw like this, okay, it suddenly moves upward. You can remember your childhood days. When you throw like this, all of a sudden it takes an upward direction. If you have any confusion, you can do it at your home and you can try to throw it. Okay. So when you throw it, it actually moves upward. Why it moves upward actually? We can explain it on the basis of this aerofoil. So this aerofoil is actually a shape, so which is usually observed in the aircraft wing. Okay. What actually happens here? when you have this kind of structure and it is moving through air, the upper part will allow more air to move compared to the lower part. See, upper part of the shape will allow more air to move over it than the lower part. Now when there is more air, what actually happens? Velocity will be more, obviously, right? More air will be moving means obviously velocity will be more. So when the velocity is more, you can understand what happens to the pressure. Pressure decreases. When the velocity is more, pressure decreases. When the pressure decreases, what happens? You can see there is easily this aeroplanes can take the proper lift. Without much difficulty, it can balance the weight of the aircraft while taking off. Okay, so normal, other than the engine power, there will be extra help for the aircraft to easily take off due to the dynamic lift. So even when the time of landing, the aircraft wings are arranged in a proper manner that, and one more thing, you cannot assign same idea over there also, because say you can just imagine if you do the reverse of this during the time of landing, what will happen? There will be sudden push downward and the aircraft is going to get crashed. So that doesn't work actually. So if you just Google or see through the YouTube, landing and taking off of aeroplane, okay, principle or idea behind, so that you can see properly the wings are fitted with certain type of sheets. Okay, it is going to open during the landing, and during the landing there are some plates like things. Okay, you can see that it actually opens and it blocks the airflow. So that's the reason where it gets some opposite push. Okay, so the aeroplane gets stopped easily. So you can see those ideas using like platforms like YouTube or Google search also you can do. So idea is that same whatever I have explained here, it is because of the structure. So even if you do make the same type of aircraft using your thermocol, you will see the same effect. When you just throw like this, it all sudden takes off. It moves in the upward direction. That is because of aerodynamic lift, or we can say like a lift of this aircraft wing. Aerodynamic lift we call. Okay, so this is the idea, basic idea, and next class we will be going to see some more idea about viscosity and surface tension and all. So this chapter is really interesting, and you need to have good reading on this. So I suggest you people to read NCERT textbook, okay, solve some problems related to this, and you can also go for NEET problems. So I'll be giving some NEET problems during this assignment and all. You people can try to solve them. Okay, and if you have any confusion, you can just ask me through the WhatsApp, or even if you have still doubt, you can call me. I'll be clearing your doubts. Okay, thank you.